On this week's Kumulus on Cloud, we're going to talk about containerization, but containerization as part of the model of moving into a cloud. So when we think about containerization, when we think about the process of using containers, there are a number of different aspects that we have to think about. And if we take a simple model, let's take a monolithic application that many enterprises have built. For example, a Ruby on Rails app, or maybe they're deploying something like a WordPress environment. It's a fairly simple system. And in fact, the application itself is often made up of a set of modules that run inside of, or is effectively a sub-process of, a web server. The only thing is that often those systems have a separate data storage environment. And I might run all that on a single virtual machine. That's fairly common. In the containerization space, I can run multiple containers on one machine as well, but I'm going to break those application pieces up into separate containers. Now, if we go back and we think a little bit about what a container is really two things, or it is described as two different things. One is a container image. This is effectively, we can think of it as the bundle of my application. And again, if I'm going to take something like a simple WordPress application where I have an application engine that runs in conjunction with a web server, like Apache or Nginx being the web server, my application code is bundled with that and runs in that same process space. That works as one container. My data storage backend, whatever that happens to be, often it's a Postgres or a MariaDB, or MySQL is the other version of the MariaDB model. In either case, I will often end up with a minimum of two containers to deal with. Now, the nice thing about containers is that when I build a container image, what I'm often putting into that image is all of the code I need to run that application. And I can often start to think about building very lightweight containers. This is a process unto itself, but I can often restrict what I'm putting into that containerized environment to be just the application, any libraries that the application itself needs, so potentially communications libraries or database access libraries, and the potential additional processes, again, like having an Nginx service plus my application code, plus my application libraries. All of that would get bundled together through the process of creating a description that then turns into that container image. Now, once I have the image, the next step to the process, of course, is to run that container. And in order to run it, I have to think about a number of different aspects. Does that container need storage? How am I going to access the storage that the container needs? Does that container itself need network service beyond just having an address presented to it to be able to get communications into and out of the container? Those are some of the resources that we have to think about as a part of deploying the container. But the biggest advantage, the reason that containers have become such a big thing, and often when you talk to anybody in the enterprise space today, their number one challenge is, how do I containerize my applications so that I can run them as more efficient systems within the cloud environment? Well, the containerization process itself is one piece of that puzzle. But when we think about doing that, and when we think about network service and storage service, we also want to make sure that we think about security service, because we can think about security in a number of different factors when we're building our application. Certainly, we should be securing our code. And we should be thinking about, even in advance of it ever being implemented in a container, how are we going to make sure that the code itself is as secure as possible? So we're going to want to be able to do static and dynamic validation of the code base itself. Now, in order to do dynamic validation, we want to be able to run the code base, or at least run through the process that the code would actually execute. And the best thing to do there is to actually containerize the application in advance of doing a dynamic check, so that we have the entire bundle of the actual state that could be used in production from that very point forward. Again, one of the real benefits is this new packaging mechanism that says we have all the resources together. So if I take this from a developer's workstation, for example, and move it into a staging environment, I have the exact same libraries. There's no question when I deploy that application that I've now pulled down a slightly newer version of a library and now have a delta between what the developer tested and what the staging environment tested. And if I then take that same model and say, if I were to, again, pull down all the resources I needed at the time of production, it could be that, again, one of those resources, or multiple of those resources even, have changed over time, and that, again, changes my application from my actual tested state. The containerization process basically gives us a frozen in time state snapshot of our application code. And I think that's incredibly powerful for being able to understand what it is that's running and where it lives within the system. So if I think about my application developer using a model, containerizing that hopefully automatically by posting their code into a Git or into a source code repository, Git being a very common one, then taking that same bundled code, doing dynamic analysis on it. When I store that code, I'm going to store that code in a container registry. And the container registries, many of the modern ones, actually have embedded in them the ability to do additional static checking so that the containers can constantly be scanned for any potential vulnerabilities. And these would come from like CVEs that are delivered by the CERT process, basically an emergency response for cybersecurity threats. Basically saying, hey, look, we found a new threat. This is where the threat is. This is the library that function that it lives in. The static checking that happens on those built container images says that, oh, well, we know that this container image has this particular vulnerability in it now because it was just discovered. And because that container image is the exact same code that we used in our production environments, we can now, if necessary, either scan through our production environments or automatically know based on the code that we pushed into those environments where that container now is running and what version it's running, so that we can update the version of the code, for example, in that container, go through that same development process, now take that newly secured container, push it into the registry where, again, it'll be constantly scanned for any new vulnerabilities, but we can then also roll that container out into our production environment. Now, the rollout process is often one of those that's a little fraught depending on how we built our application. Obviously, if I have a single application and a single application container running, deleting that container and restarting it is going to create an impact. The question is, how big of an impact is that going to create? And did I introduce any new bugs when I did that? One of the nicest things about the container environment is because the containers themselves are versioned, I can have the current running version and the new version on the system at the same time, installed and ready to go. And depending on what it actually takes to turn the application on, if there's no database migration that has to occur, in reality, all I'm trying to do is launch a process, the impact to the environment might be on the order of seconds or even less in terms of turning one container off and turning another container on. Now, in an environment where you only have a single container, the chance of that container being a mission-critical application, I'm going to guess, is fairly low. So the impact of being able to say, hey, look, I can find a security vulnerability and fix it, and potentially fix it within a couple of seconds, effectively in the retry timeout of a user at their web browser where their connection failed for some reason, is actually, I think, pretty compelling. In addition, if that upgrade for whatever reason fails, I still have the previous version on the system ready to go. So I can turn the upgraded system off and turn the other one back on with as little impact as possible to my end users, other than the fact that they're probably running into some form of bug that we didn't manage to test as a part of our distribution and test process, which is something we should also catch. And again, this is one of the other areas where, again, containers really can help with an application, even one that was effectively classically deployed just as a VM through maybe some automation process, is the ability to make sure that I am able to easily go through stage testing and validation processes for those different resources. And I think it's because of the containerization process, the 12-factor application development process, the cloud native mindset. Oh, well, let's not treat these services as unique special instances that have to be babied. Instead, let's just think about them as things that we can throw away anytime there's even the smallest fault. Throw it away and start another instance to replace that. That mindset has changed how we think about resources, and containerization just makes it a little bit more operationally efficient. So I'm a huge fan of containerizing every application that we possibly can. There are some caveats. Not everything can easily be containerized just right off the bat. And usually things that require on older libraries or only work with older Linux kernels is usually the interaction stage, may not be able to run in a modern containerized environment. And so that's something to consider, that some of those applications might really be highly leveraged candidates for being updated into potentially a new systems model, which does not by any means, by the way, have to be microservices, which is something we'll talk about in another episode here shortly. But within the containerization space, we really do see an interest in and the benefits of being able to more rapidly turn over our applications. We can make them more secure, which is really important, as we've again discussed in a previous session. The security aspect of containerized applications is yet a whole nother topic, but security in general, if we can improve our security because we've accelerated the time between an error or a failure being found, a cert being delivered about a problem within the potential libraries that we're using, or CVE rather, being published against the libraries that we're using, discovering which environments it has, and getting that system turned over rapidly is really one of the biggest benefits of this containerization process. And I think it's something that's fairly straightforward to do for most enterprise applications, especially smaller ones. For the most part, it's just looking at how the application is being deployed and restructuring that to either rewrite it for the container model and then the container operations model potentially as well, or with even more modern container services, if we're using a tool like Kubernetes, it's really just coming up with a new description for how the application should run and whether or not it has any scale potential. Can I actually run 2, 3, 4, 5 web front ends in front of my application to scale the application? If I can describe that in a Kubernetes document instead of having to try to manually figure out how to scale the system up and down within the environment. So containers are really powerful tools. The packaging model is one of the core value propositions, and it's one of the ways that we can actually take our old enterprises and move them into the new system space. We have potentially better security visibility and security remediation processes that we can make easily available through the process of containerization, and just the speed by which we can deploy, redeploy, upgrade, potentially even downgrade our applications makes it more viable or more possible to actually make those changes even in the middle of the day rather than only during specific windows where our users are less likely to be online. And in an internet-attached global economy, we always have users online. Well, folks, thanks for watching. If you liked it, don't forget to like it. Hit that thumbs up button. We always like to know that we're doing a good job. Don't forget to share this with your friends, and just to make sure that you get the latest and greatest episodes that we release, hit that subscribe button, and don't forget to hit the little bell next to it so that you actually can get notified when they come out. Thanks so much for joining us.